All right, so we're going to prove the perpendicular bisector theorem, which states that a point is on the perpendicular bisector of a segment if and only if the point is equidistant from the endpoints of the segment. So in other words, we have this diagram here. We know that CD is the perpendicular bisector of AB if and only if AC is congruent to BC, where CD is perpendicular to AB. All right, so let's go ahead and start this proof. And let's do the P implies Q direction first, right? So we're going to assume CD is the perpendicular bisector of AB, right? So if CD is the perpendicular bisector of AB, this implies that the measure of angle CDA is equal to 90, which is equal to the measure of angle CDB. And it also implies that AD is congruent to DB, right? Okay, so we have this is congruent to this here, and of course, if these two equal 90, they are congruent, right? So hopefully you can see that if you look at triangle ACD and BCD, these two are congruent by side angle side, right? So, well, we have AD is congruent to DB. We have angle CDA is congruent to angle CDB. And we have CD is, of course, congruent to itself, right? So these three things together imply, by side angle side, that triangle ADC is congruent to triangle BDC. And if these two triangles are congruent, that means that AC must be congruent to BC, right? That means these two must be congruent. So we have, so this implies that AC is congruent to BC with CD perpendicular to AB, which is exactly what we wanted to show, right? Now let's go the other way. So we're going to do Q implies P. So we're going to assume in this case that AC is congruent to BC, where CD is perpendicular to AB. All right, so we have CD is perpendicular to AB. Let me put a line over there. This implies, of course, that the measure of angle of ADC is equal to 90, which is equal to the measure of angle BDC. And of course, this implies that angle ADC is congruent to angle BDC. And of course, we have this is congruent to this. We have AC is congruent to BC. And if you were to think about this triangle ACB, if we know this is an isosceles triangle because at least two sides are congruent, right? And remember, by the isosceles triangle theorem, right, we know that if these two sides are congruent, the angles opposite those sides are also congruent. So this implies that angle CAD is congruent to angle CBD. And hopefully you can see now, by angle side, right, triangle ACD is congruent to triangle BCD, right? Scoot it down. Well, we have angle ADC is congruent to angle BDC. We have angle CAD is congruent to angle CBD, and we have AC congruent to BC. So these three things together imply by angle, angle, side, that triangle ACD is congruent to triangle BCD. And if these two triangles are congruent, of course, that means AD is congruent to BD, right? So if we have CD, so we have CD is perpendicular to AB, right? With AD congruent to BD, right? If we have CD perpendicular to AB where AD is congruent to DB or BD, this implies that CD is the perpendicular bisector of AB. And that is our proof for the perpendicular bisector theorem.